Hi, and welcome to the fourth section of the Mastering TypeScript Programming Techniques course,
where we'll learn about stepping into object-oriented concepts.
In this section, we'll learn how to create and implement a TypeScript interface, how to extend a class, how to hide the data with abstraction, and how to use access modifiers. We'll get familiar with TypeScript interfaces, and we'll learn how to create and implement them. An interface in TypeScript allows us to define what shapes an object can have, and since we are using TypeScript, we can also specify the data type for the object properties. Furthermore, we can also specify if a certain property should be optional or not. On top of these interfaces, let us define a string index for objects where we want to accept extra properties for our objects. You can think of these interfaces as contracts that an implementer must implement. Interfaces can also extend other interfaces by copying members of one interface to another. And this type of behavior encourages the creation of reusable components. On the top of being able to define shapes of an object, interfaces in TypeScript can also describe function types by essentially defining the function with a parameter list and a return type. Let's take a look at a few examples. Interfaces can be created in separate files, but to keep things simple, I'm going to create them within the same file where we are going to implement them. Should they be in another file, a simple import statement would suffice to bring them in. So first, let's create an interface to describe an object. You don't necessarily have to call your interfaces prefixed with the letter I. I just like to keep that to remind myself that I'm working with an interface. Once we have defined the interface, we can add properties along with data types. Now we can go ahead and create an actual object that will implement this iPerson interface. And notice that if I do not specify any properties for my object, I get a warning from TypeScript saying that an empty object is not assignable to type iPerson because the property name is missing in the type. So we need to add that. And of course, it's still going to complain because now we are missing the age property. So let's go ahead and add that as well. Once we add both of these properties, all warnings disappear from my editor. Also notice that we need to make sure that the data types match. So if I add the age as a string, then again we'll get a warning that says type string is not assignable to type number. Now of course there may be situations where you want to have a property that is optional. So we can define optional properties at our interface by adding a question mark to the name of the property. So here we say that every object that implements the iPerson interface should have a name and an age property, and optionally they can have a hobby property as well, which should be an array of strings. So that means that I can add a hobby with some values, and this now implements my interface correctly. But if I leave out this particular property, that also implements my interface. Now what happens when you want to add any number of additional properties? So we can set up our interface in a way so that we have a name and an age property that is required, and then we can set up what is called a string index signature that can specify that we can add any number of properties with any type. And we need to use the square brackets to do that. Specify the property to be of a data type, and it can either return a string or we can have any data types. And in this case, we can add whatever properties we want to to our user object, and we still won't get any errors. Now, as discussed during the presentation part, we can add interfaces for functions as well by defining the parameter list and the return type. So let's go ahead and create another interface. We're going to specify an interface called myFn, my function, and now we need to specify the parameter list and a return type for this particular function. And when creating functions, we can let TypeScript know that this particular function should implement the interface that we have created. And here we have the implementation of that interface. Please note that if you don't need to use the same parameters that you've specified in the interface. So this could be my number 1 and my number 2, of course making sure that you also update the return statement to incorporate this. And this is still going to be a valid function signature. And last but not least, let's take a look at an example and see how interfaces can extend another interface. So I'm going to create two interfaces. So I have the first interface iPerson, then I have a second interface that extends that interface and is called iStudent. So basically the iStudent interface will have the name property as well as the class property. So let's go ahead and test this. So here I am using type assertion. So I'm creating an object that should implement the iStudent interface. And I can go ahead and assign properties to this particular interface now. And notice that if I try to add a property that I have not defined in either the iPerson or the iStudent interface, I will get a warning. And the warning states that property age does not exist on type iStudent.